Since we launched the first artificial satellite in 1957, the satellites orbiting the Earth have dramatically increased, and predictions suggest that thousands more will be launched in the following decades. This raises a growing concern in the space community, leading to more initiatives to better our space situational awareness. One of these initiatives involves the use of the emerging technology of event-based sensor for space imaging. These sensors function similar to a human retina, wherein each of its pixels work independently to produce low latency and high temporal resolution data. So unlike optical sensors, event-based sensors are less prone to motion blur and can even detect space objects during daytime. The use of event-based cameras for space observation is a new and promising approach. Hence, for this study, we propose a simulation of resident space object tracking for space situational awareness using event-based vision. We chose to observe the International Space Station in a geosynchronous satellite ABS-6 from Quezon City on March 16. Given the longitude and latitude of the location and the orbital parameters of the objects, we used the SGP-4 model to propagate their orbits for 24 hours. This results to the satellite passes, which provides us an idea of where and when to point a telescope or sensor. In setting up the telescope, we chose its specifications to be similar to the Davis event sensor. We then perform a mnemonic projection to accurately map their trajectory from a 3D sphere to a 2D plane. This involves transforming azimuth and elevation values to the equatorial coordinates, then to the standard coordinates, and lastly to the pixel coordinates. This gives us the final satellite trajectory seen by the sensor. Overall, the pipeline can be readily extended to track any resident space object from anywhere at any time. It can also be used as a basis for developing tools for planning future observations, as well as for assessing the feasibility of further applications such as satellite orbit determination.